In this video, we're going to talk about how we'll power our Instagram clone called InstaFire. The motivating question here is, how does your app use data? No matter what you're building, data is central to the experience that you're delivering to users. You need a way to store and retrieve data to show it in your application. And you have a couple ways to do this. First, you could use a third-party API like Yelp. In order to retrieve rating or review information for restaurants around you, you could talk to the Yelp API, get data back, and show that in your application. The other option, which is what most app developers and startups will do, is to use your own backend. And this gives you the maximum flexibility to define how you want to structure your data and how you want to modify or create your data. And that's where Firebase comes in. Firebase is a backend as a service. So we can focus our time on building our mobile app rather than having to worry about the backend. So 10 or 15 years ago, if you wanted to build out a client application, your first headache would have to be buying a server, connecting it to the internet, installing a bunch of software on it, and then having your mobile app talk to that backend server. With Firebase, all of that complexity is taken away. All we have to do is go to the Firebase console, allocate a server, allocate some data for us, and then our client, our mobile app, can retrieve that data really easily. And I'll show you how to do that in the upcoming videos. By the way, if you are interested in how to use a third-party API like Yelp in your application, I'll leave a link in the description to a walkthrough where we actually integrated with the Yelp API. But talking more about Firebase, it's an app development platform developed by Google. And Firebase is really, really broad. There's many different components in Firebase beyond what we'll use in this walkthrough video. So the cool thing about this is that as your app grows in complexity and sophistication, as you start adding more features, there's a really good chance that Firebase will have something there to support you. It has everything from crash analytics to sending out push notifications. The three services that we're going to use are number one, authentication for user sign-in, Firebase storage for storing the photos of our Instagram posts, and finally, Firestore, which is for the database. So I think authentication and storage, I'll show you how to use them as we get to the implementation of them, but they're fairly straightforward. So I want to spend more time talking about Firestore and how we're going to structure our database. And one side note about Firebase is the other cool thing about it is that it's totally free for small apps. The way the model works is that as a small app or as a small company, you don't have to pay anything to Firebase. But if your app really takes off and you get a bunch of users, that's when Firebase will start to charge you. So what is Firestore? Firestore is a NoSQL cloud database to store and sync data. Let's unpack what that means a little bit. Traditionally, when you want to store data, there are two options, either SQL databases or NoSQL. So SQL stands for Structured Query Language. And basically, it's a way to store your data in a very structured way, where you have rows and columns, and each object that you're talking about is typically represented by one row in your database. On the other hand, Firestore is an example of a NoSQL database. As the name implies, it's not structured, so it's a NoSQL database, meaning that it doesn't adhere to the same strict structure that SQL databases will have. Cloud database means that Firestore lives in a server somewhere. It doesn't live locally on your device, but somewhere in the cloud. And the cool thing about Firestore, which I'll show you when we get to the implementation, is that it automatically will store and sync data. So if you make a change in the cloud, let's say you change your username, then automatically all the clients will get that update. Or if another client, so let's say that someone else changes their username, all the connected clients will get that update immediately, which is really, really powerful. The Firestore is made up of documents and collections. Documents are like JSON objects, which have fields of various types. Each document is part of a collection. The reason I like Firestore is that it gives you a lot of flexibility. Because it's NoSQL and there's not a really strict structure to the documents, you can actually add arbitrary key values, and that allows you to move a lot faster. So in our application, we're going to have two entities, or in this case, two collections in Firestore that live inside the root, posts and users. Inside of each collection are a bunch of documents. So in this example, we have 3 posts that live inside the post collection, and 2 user documents that live inside the user collection. So filling in the diagram a bit more, each document will have different attributes. If we take a look at a screenshot of our application, here's the main screen, which shows a list of posts. There are 2 posts on the screen now, and you can just take a look at what we're showing. So obviously we're showing the key information about the post, such as how long ago it was created, the image of that post, and a description. But also, importantly, we're showing the author of that post. We're showing the user who created it. So in that top example, you have a profile picture of Nathan and his username. And that will educate how we structure our data. So in addition to just having the simple attributes of the post or user, we also want to embed the author of that post in the post document. And this is the consequence of having a NoSQL database. We need to actually copy over some of the data about the author from the user document and embed it into the post. And this might be weird if you're coming from a SQL background, because it is kind of violating the principle of data normalization. If that doesn't make sense to you, don't worry about it. But the key takeaway here is that we want to embed the user information inside the post. Here's a screenshot from the Firebase console that I took. We have 2 collections, like we talked about, posts and users. Inside of posts, you can see there's a bunch of documents, and the weird strings that you're seeing here are IDs that are generated for us by Firebase. If you look inside the first document, you can see the attributes that we talked about: creation time, description, and image URL, along with a JSON object, which is the user. So with this knowledge in hand, now we can come up with the implementation plan. The first thing we'll do is worry about login and authentication. So we'll build the UI for login and hook it up with Firebase authentication. And after that, we'll create fake user data along with some fake posts so we can make our app more interesting. The first thing we want to do once we have that fake data is be able to retrieve posts. So the first thing we'll do is don't worry about the UI, but just make a query to Firebase to get posts for our app. And then second, we'll use a recycler view component to display the posts. And then the second thing we want to do is the creation flow. So for that, the first thing we'll do is the UI. And then the second, we'll hook that up with Firebase to actually publish this and put it into the cloud, the new post that we create. If you have any questions about Firebase or how we're going to go about building our app, drop a comment and I'd love to help. But with this knowledge in hand, we are prepared now to create a brand new project in the next video and start building out InstaFire. See you in the next one.